Final speaker for today is Letice Bussiere. She is a doctoral student at University of North Carolina, Charlotte, who received a NASA Internship Award at Marshall Space Flight Center through the 2021-2022 school year. And her research is focused on creating a technical handbook for NASA's disruptive modal coupling concepts and technologies. So Letice, if you're ready, you can go ahead and start.
Thank you. Yes, as you said, my name is Letice Bussiere. I'm a first-year doctoral student studying mechanical engineering at UNC Charlotte. In the summer of 21, I received a NASA Internship Award and virtually interned at the Marshall Space Flight Center. This is actually my second internship at Marshall, and I was given the opportunity to intern with the same team from my 2019 internship. The focus of my internship was to create a technical handbook that would detail the origin of certain concepts and technologies for NASA's disruptive modal coupling team. Since the internship was virtual, we actually had an intern team of 6 individuals. As a returning intern and the only graduate student, I actually had the opportunity to lead the team. So on top of working on the technical handbook, I was also given the responsibility to create workly week schedules for each intern, as well as lead meetings to ensure that our deadlines were met and our quality work was being completed. I've also included a list of engineers that we had the opportunity to work with while we were interning. And the EV31 department is known as the Spacecraft and Vehicle Systems Department. So during this whole internship, our intern team was working to produce a technical handbook that would contain the development of concepts and technologies for the disruptive modal coupling team. My team was actually the first to work on this task, so we were laying out the origins of key technology that they use today in their research. So within the handbook, we summarized the bulk of research over the years 2009 to 2011. This research included key results and figures from data collection and analysis, as well as important information covered in presentations and reports. With each summary, we provided a link that would allow readers to view the original document that the information was referenced from. And while most of what our team handled was controlled information, I would like to present a general overview of the technologies we worked to provide a history for. And since the team's focus was on the origin, it's important to actually begin with NASA's Ares 1 rocket. So the Ares 1 rocket had an issue identified after a test flight, which is identified as thrust oscillations or resonant burning. Since this is a 5-segment solid rocket booster, or SRB, it's not uncommon for the phenomenon to occur, but the concern was that the vibrations were actually reaching the crew exploration vehicle. So the frequency of these vibrations was found to be around 12 hertz, and at this frequency, it actually impaired the astronauts' abilities to perform routine functions such as reading displays. A handful of solutions were identified, but the mitigation system I would like to focus on is the lock stamper. This was an alternative solution designed as a risk mitigation system as opposed to a primary solution, but it is the solution that the EV31 team developed and has continued research on today. So the lock stamper, or otherwise known as a liquid oxygen damper, is a device placed within the liquid oxygen tank of the Ares 1 rocket. Unfortunately, again, due to the nature of the information, I'm not able to provide figures to depict the operation or design of the damper, but I can give an overview of the concepts behind the device. This damper controlled vibrations produced by thrust oscillations by using the liquid's propellant mass to generate momentum. This momentum generated would essentially disrupt the oscillation by countering the vehicle's acoustic response. This technology, developed as a solution to the issue, presented such promising results that when the Constellation program was canceled in 2010, the EV31 team continued their research efforts on the topic, and the team is still improving it to this day. Lastly, I would like to touch on the current research efforts of the team. 2 developments after the lock stamper included rotational tension element damping and fluid structure coupling. These concepts were exported through NASA's technology transfer program and both have patents pending. The technology transfer program helps to make NASA technology developed for discovery and exploration available to the public to maximize its benefits. Both of these concepts utilize principles found in the development of the lock stamper for different applications. The RTED disrupts vibrations using feedback from things such as compression cycles, while fluid structure coupling uses the coupling between fluids and structures to work with the system's dynamics. An example of the FSC in action is provided to the figure to your right. As you can see, the implementation of the device actually successfully mitigated the magnitude of the response. The device has been producing such promising results that it was actually implemented in the Barclays Center in Brooklyn, New York. Each technology has a wide variety of applications, and thanks to the technology transfer program, we can actually see the many benefits of the research that all began in 2009 with the Ares 1 rocket. And thank you to the Space Grant for this opportunity, and thank you to my mentor who has really been a great resource inside and outside of my internships. Thank you.
All right, great. That was a really interesting talk. I know a lot of folks at my center, NASA Glenn, have worked on the Ares rocket. And as you mentioned, they discontinued it, but it still feeds into a lot of the new work they're doing with the Space Launch System, SLS, and some of the newer hardware. So that was pretty interesting. I don't see any questions in there, but I guess, let's see. Yeah, I think this was for you. So can you speak more about how the implementation of your research has informed some of the more current work?
I actually cannot. A lot of that is information I'm not allowed to speak on. I wish I could, but a lot of work has actually resulted from it. Unfortunately, I can't give any specifics, but they have a handful of new projects in development that have resulted from the research that we did to create like a handbook that would show them where everything originated from. And so yeah, that's about as much as I can say, but it's a good question.